This video provides a detailed, step-by-step guide for performing ASTM C157, the standard test method used to determine the change in length of hardened hydraulic cement mortar and concrete specimens. The length change can be caused by various factors, but this test is primarily used to assess drying shrinkage. The procedure involves molding prismatic specimens, curing them under controlled conditions, and measuring their length at regular intervals. The results are expressed as a percentage change from an initial measurement. This test is crucial for evaluating the potential for cracking and dimensional instability of concrete and mortar mixtures. The primary significance of this test is to provide a standardized method for evaluating the volumetric stability of concrete and mortar mixtures. Drying shrinkage. The most common application is to measure the shrinkage that occurs as concrete dries. Excessive drying shrinkage can lead to tensile stresses that, if they exceed the material's tensile strength, will cause cracking. Material comparison. It allows for the comparison of different mixture designs. Cementitious materials, aggregates, or admixtures in terms of their effect on length change. Predicting performance. The data can be used to predict the long-term performance of a concrete mixture in a structure, particularly its susceptibility to shrinkage-related cracking. Expansion measurement. The method can also be used to measure potential expansion, such as that caused by alkali-silica reaction, ASR, or sulfate attack, by storing the specimens in a reactive solution or water. All apparatus must conform to the requirements of ASTM C490. Molds. Prismatic molds with a nominal cross-section of 1 by 1 inches for mortar or 3 by 3 inches for concrete, and a gauge length of 10 inches. The molds must be rigid and fitted with gauge studs at each end. Gauge studs, stainless steel or other corrosion-resistant metal studs that are cast into the ends of the specimen. They have a rounded or hemispherical tip for precise measurement. Length comparator. A dial gauge or digital indicator mounted in a rigid frame, designed to measure the distance between the ends of the gauge studs. It must have a reference bar, made of a low thermal expansion material, to set the 0 point. The apparatus must be capable of reading to 0.0001 inches. Tamping rod. A round, straight steel rod with a hemispherical tip, conforming to the dimensions specified in ASTM C192. Curing environment. Moist cabinet or room. Must meet the requirements of ASTM C511, capable of maintaining a temperature of 23.0. Before each reading, ensure the ends of the gauge studs are clean. Place the reference bar in the comparator and set the dial gauge to the reading corresponding to the reference bar's length. Place the specimen in the comparator, ensuring the gauge studs are properly seated. Record the reading to the nearest 0.0001 inch. Rotate the specimen and take a second reading. The two readings should be averaged. If they differ by more than 0.001 inch, the measurement is suspect and should be repeated. All readings should be taken at specified intervals. The length change is calculated as a percentage of the effective gauge length. For example, if gauge length G equals 10 inches, initial comparator reading equals 0.2452 inch. Comparator reading at 28 days equals 0.2402 inch. Length change at age 28 equals negative 0.050%. The negative sign indicates shrinkage. A positive result would indicate expansion. For more information, contact our friendly team today.